So basically, today we're going to cover the chapter of probability and the basic um, stuff of the percentages that you're going to be tested on for the ICTs. So, frankly, the probability is just represented by the following equation, and nearly every single question that is related to probabilities and you're going to be asked on for the ACT is going to be just represented by the following equation, which is you have a certain sample, and there are certain outcomes, and for each single outcome you have some sort of numbers that represent that outcome. So in that test, or on the question, what is he going to ask you is that you get the probability of choosing certain outcome, and you base your answer depending on the entire, or the number in group under consideration, or the total possible outcomes concerning that specific outcome. So as it's written on the screen is that you have a number of a target outcome. So the target that you are seeking to get the probability of choosing it, or the probability of that being chosen from a group of people, a random examination that is going to pick out some different number of students, and within that target you're choosing the total number, and you're going to divide them by the total possible outcome of the entire sample. So target out of total is going to be the probability. Okay, so this is almost everything about the probability that you're going to be asked. We are going to solve some questions that are assigned by the college board. Let's start with the example that is given by the college Panda. As I have said before, this is a very useful book for ACT beginners. You're going to find it very useful and helpful. Okay, so an example, when it says that the table above summarizes the meet preferences of passengers on a particular flight. So if a first class passenger is chosen at random from this flight, what is the probability that the passenger chosen prefers beef? So basically this table just summarizes, gives you a sample where different number of people on a certain flight have some sort of meat preference, and they are going to choose between beef and the chicken. Okay, so there is a certain category, which is the first class. That's the first one, and the second one is the coach. Okay, you have, for the first class, you have 18 people or students or passengers have chosen beef over chicken, and you have 27 who have chosen chicken over beef. Same goes for the coach, 60 to 138. So we are going to now specify what exactly is he seeking. So he said if a first class is chosen at random, so he's now choosing from that category, which is the first class. So we have to focus on that only and eliminate the coach column. So the probability that the passenger chosen prefers beef, so we have that the total number of passengers who have had the preferred beef is 18. So that's the target over the total number. So we have the total number of passengers in the first class preferring either beef or chicken. The total number is 18 plus 27. 18 plus 27, which is going to be 45. So 18 over 45 is going to be 2 out of 5. For sure, this is the total number of possible outcomes. So the answer is what? B. Okay, so this is a very simple question that is involved in the chapter of probability, and the reason is that that I have chosen that is depending on the preferences of our students. Okay, so we are now going to shift for some questions by the college board. So just give me a second, I'll be shifting to them. Okay, so these questions are from college board, and that's the ID for that question, and it's the domain is problem solving and data analysis, and the skill as it's provided the probability and conditional probability. Okay, so and this question difficulty is hard. Okay, so let's read the headline of the question. It says that the same 20 contestants on each of 3 days answered 5 questions in order to win a prize. Each contestant received 1 point for each correct answer. The number of contestants receiving blah 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 blah. These stuff are just giving you the information about the table, so you can just head directly to the intended question. This is going to save you much more time. It's a really great technique. You head to the question that is intended for the entire thing. So it says that if a contestant is selected at random, the probability that the selected contestant received a score of 5 on day 2 or day 3. So we are looking for a score of 5. So this is a score of 5, and he specified that or limited it to only day 2 and day 3. So we have day 2 and day 3. There are only 2 on day 2 who received score 5 out of 5, and on day 3 there are 3 only. Okay, so and it says that given that that the contestant received a score of 5 on one of the 3 days. Since he gave you the word given that, you can know directly that this is going to be the total number of possible outcomes, which we have discussed earlier. So it says that the contestants received a score of 5 on either of the 3 days. So day 1, day 2, day 3. The total is given is, as it's mentioned, it's 7. So the total is 7, and we have day 2 and day 3, 2 plus 3, which is equal 5 over 7. So this is the final answer. Okay. So moving on, we have this answer which says that on each face of a fair 14-sided die is labeled with the number of from 1 through 14. Okay, with a different number appearing on each face. If the die is rolled one time, what is the probability of rolling a 2? He said that it's a fair dice, so since it's rolled on only one time, the probability of falling 2 is 1 out of the total outcome. So you have only one face where number 2 appears on, and we have 14 total outcome. And you are given that it has only rolled one time, although if it's given that rolled more than one time, the total the probability that you're going to get for 2 is going to be just the same, 1 over 14, regardless the total number of rolling the die. Okay, so the final answer is A, 1 over 14. Of course, it's not 2 over 14, nor 12 or 13. Okay, so moving on, we're going to move to that question. Okay, it says that Jennifer bought, and by the way, this question challenges something else, which is percentages. So we can just skip it and come to it later on, because we are let's just focus just on the probability questions. Okay, so this is a probability, and the difficulty is in consideration. We are given that it's a type of car, and he selected among all these a non-hybrid, either hybrid or non-hybrid, and they are selected within also these two categories. So you're going to choose the probability that the selected car is going to be a hybrid and a no more than 25,000. So it's going to be 2, since this is the favored outcome, and the total possible outcome, or the total, as I have mentioned recently, the total is going to be 14. 2 out of 14, which is going to be 1 out of 14, out of 7, I mean. Okay, so the reason that I haven't limited it to that column is that we are choosing a car that is a hybrid and limited to a price that is no more than 25. That doesn't exceed 25,000. So the car that has been chosen is between non-hybrid or hybrid. So you're going to get that table and pick one car out of 14 different cars, and 2 of them that you're favoring, or the desired pick that you have picked is 2 out of 14. So 2 out of 14 is 1/7. That's the probability that the final answer is 1/7 out of 7. Okay, so moving on. This is also a percentage question, so we can just skip it. The problem with that file is that the course, our original course, was we were discussing the entire domain for the problem solving and data analysis. So there is a certain misunderstanding in that kind of session, because we already have an online course that is ongoing for the March trial. Of course, if you wish to join us, we can let you join, and you can follow up with us. Okay, so this is a scale probability and conditional probabilities also as well, and this is easy. Okay, so we have a marble that is chosen at random from the back. So this is the same as the prior one, but with a more simple concept. So what is the probability that the marble will be blue? So we are choosing a marble out of a bag, from a bag, and this bag contains 40 different or a total of marbles, each with different color. Okay, so the probability that the marble will be blue, we have a blue marble, the color is blue, and we have 10 blue colored as blue, and the total is 40. So we desired out of the outcome, a total outcome, so it's D. Okay, so this is also a probability and conditional, and it's easy. Okay, so we can head to the headline of the question, or the intended question from that table. We have that based on the data in the table, what's the probability that the gas station customer selected at random on that day didn't purchase gasoline? Okay, so he needs the probability that the gas station customer selected at random, okay, on that day didn't purchase a gasoline. So we have a total number of, we have a gasoline purchased, beverage purchased, and beverage not purchased. And based on the given information, we need to select a customer on that day where we have or we need to get the probability that that customer, whether he purchased beverage or not, we need to know if he purchased gasoline or not. So this is the intended thing. We ignore beverage. This is not included, so we're going to include it. What we are going to focus on, we are going to focus on the gasoline. So he need that he didn't purchase gasoline. The total number of customers who didn't purchase gasoline is 50. So this is the desired out of the total number. Since they are 50 and the total number is 135. So we have 50 out of 135. So this question is just testing you whether you're focusing or not. He needs you to focus only on that row, and you ignore the privilege. So it's 50 out of 135, which is D. Okay, so moving on. This is a probability and conditional, that's medium. Okay, that data on the code color and eye color for 48 Himalayan kittens available for adoption were collected and summarized in the table above. What fraction of the chocolate colored kittens has deep blue eyes? Okay, we have total of 48 kittens, and we have a coat color and eye color. Some with a coat color of cream, and the other chocolate, and the eye color deep blue and light brown. Okay, so we have total number of chocolate colored kittens, and you need them to be deep blue eyes. So we're focusing on that row only. Why are we focusing on? So because he needs to know by what fraction does the chocolate deep blue represent from the total number of all chocolate colored kittens. So those who have deep blue eye, by what fraction does they play in that total number of chocolate kittens? Okay, so we need to deem that column or row, I mean. Okay, so we have the total number of deep blue kittens, chocolate kittens, is 12, and if we so this is 12, and if we took in consideration whether they are light brown or deep blue, we have that the total number of deep blue kittens or chocolate colored kittens are 12 out of 16. So we have the desired out of the total number of the chocolate colored kittens. So the final answer is D. Okay, so that's all for today, and we're going to cover more sections for the basic course, and the reason that I have made that free session for the probability is because that most of our students in that channel asked for it. Mostly everyone in or to be more clear, specific that is that most of the students have voted in the poll for that section. So if you have anything to ask, you can reach out to me privately, or you can just post a comment on that channel, and I will be contacting you as soon as possible. And if you have any trouble with the basics, you can reach out to me, and I will be performing a free session discussing that section or lesson. Okay, thank you. and we're going to meet soon.